Your solar system feels like home. 8 planets orbiting our sun in a neat, orderly, predictable dance. For centuries, we believed this was the extent of our family. That beyond the distant, icy orbit of Neptune, there was nothing but a quiet, frozen wasteland. A dark frontier leading to the void between the stars. We thought we had a complete map of our own backyard. Thought the map is wrong. Out here in the cold and the dark, something is amiss. The most distant objects we can see are not behaving as they should. Their orbits are twisted, clustered, and aligned in a way that makes no statistical sense. It's as if they are being herded by an invisible shepherd, their paths shaped by a gravitational force we cannot see. This isn't science fiction. It is a profound astronomical mystery, and it has led the world's best astronomers to a startling and revolutionary conclusion. There is something else out there. Something massive, hidden giant, lurking in the darkness, silently tugging at the edges of our solar system. And the hunt to find this unseen world is on. To understand how we can hunt for a planet we can't see, we have to look back to the 1840s. At the time, there were only 7 known planets, but the 7th, Uranus, was misbehaving. It refused to follow its predicted path. It was wobbling in its orbit, sometimes speeding up, sometimes slowing down, as if something were pulling on it. A brilliant and stubborn French mathematician named Urbain Le Verrier became obsessed with this problem. He believed the only explanation was that there was an 8th planet, a massive, unseen world whose gravity was tugging on Uranus across millions of miles of empty space. He didn't use a telescope, he used a pen and paper. For months, he performed fantastically complex calculations, using the laws of Newtonian physics to predict the mass and the precise location of this ghost planet. In 1846, he sent a letter to the Berlin Observatory with a simple request: point your telescope to this exact spot in the sky. The astronomer at the observatory, Johann Galle, was skeptical, but he did as instructed. On the very first night of looking, less than 1 degree away from Le Verrier's predicted position, he found it. A pale blue dot, the planet Neptune. This was one of the greatest triumphs in the history of science. It proved that gravity never lies. Its invisible influence can betray the presence of even the most hidden objects. This principle, finding a world not with light, but with math, is the exact same principle being used today to hunt for a new, an even more mysterious hidden planet in our own solar system. The modern hunt began not with a wobble, but with a cluster. In the early 2010s, astronomers began discovering a new class of objects, trans-Neptunian objects, or TNOs, worlds like Sedna and the Goblin, whose orbits are so vast they take thousands of years to circle the sun. As they mapped more of these distant bodies to Caltech astronomers, Mike Brown and Konstantin Batygin noticed something deeply strange. First, the orbits of the 6 most distant objects were all clustered together. Imagine their long elliptical paths as giant pointers. All 6 pointers were aimed in the same direction, into the same quadrant of the solar system. The odds of that happening by pure chance were minuscule, at about 1 in 14,000. Second, the orbits of all these objects were tilted at the same angle, about 30 degrees relative to the flat plane where all the other planets orbit. It was as if a massive, unseen, tilted object was gravitationally dragging them into its own orbital plane. Brown and Batygin were stunned. This wasn't random noise. This was evidence. They spent years running computer simulations, trying to find an explanation. When they plugged in a hypothetical new planet, which they nicknamed Planet 9, the puzzle snapped into place. Their model predicted that a planet about 5 to 10 times the mass of Earth, on a strange, elongated, and tilted orbit, would perfectly explain the bizarre clustering of the TNOs. It would act as a great cosmic shepherd, corralling these distant objects into the exact patterns we observe. The model didn't just explain the clustering. It also explained other long-standing mysteries of the solar system, like the strange 6-degree tilt of the sun itself, and the existence of TNOs with bizarre backwards orbits. Planet 9 was the ghost in the machine, a single, elegant solution to half a dozen different cosmic problems. So what is Planet 9? Based on the models, it's likely not a gas giant like Jupiter, but a super-Earth, or a mini-Neptune, a dense, icy world with a rocky core, hundreds of times farther from the sun than we are. At that distance, it would be unimaginably cold and dark. its year would be immense, taking anywhere from 10,000 to 20,000 Earth years to complete a single trip around our sun. But where did it come from? There are two leading theories. The first is that Planet 9 is a rogue, an orphan planet that was born in another solar system and in the deep past, drifted through interstellar space until it was captured by the gravity of our own sun. We would be living with an alien world in our own backyard. The second theory is that Planet 9 is a banished sibling, that it originally formed much closer to the Sun alongside Jupiter and Saturn. But an early gravitational wrestling match with one of these gas giants flung it out into the far reaches of the solar system, where it has been silently orbiting ever since. The gravitational evidence is compelling, but if it's there, why can't we find it? The challenge is almost incomprehensibly vast. At its estimated distance, Planet 9 would be billions of times fainter than Neptune. And because it's so far away, it would be moving incredibly slowly against the backdrop of distant stars. Searching for it is like trying to find a single black piece of sand, moving at less than a snail's pace, on a beach the size of a city. At night, using only a flashlight. But the hunt is on. The world's most powerful telescopes, like Subaru in Hawaii, are scanning the predicted orbital path. Our best hope lies with the new Vera C. Rubin Observatory in Chile, which will survey the entire southern sky every few nights. Its unprecedented power is expected to either find Planet 9 within the next decade, or prove that the gravitational whispers are coming from something else entirely. We stand at a remarkable moment in history, one that mirrors the 1840s, just as Leverrier predicted Neptune with mathematics. Brown and Batajan have given us a treasure map with gravity as their guide, pointing to a new world. Whether we find Planet 9 next year, or discover the gravitational tug is caused by a different phenomenon, the quest has already changed our perception of our home. It has taught us that our solar system doesn't just end neatly after Neptune. It has a vast, dark, and mysterious frontier that is far from empty. The neat family of 8 planets we learned about in school is likely an incomplete picture. Our home is bigger, messier, and far more interesting than we ever knew. The evidence for Planet 9 is a set of gravitational footprints leading us toward the edge of the map. It is a reminder that even in our own cosmic backyard, there are still giants lurking in the shadows. And it leaves us with a final, profound question. What other secrets? What other hidden worlds are still orbiting out there in the cold and the dark, their existence only betrayed by the faintest gravitational whisper? The search for Planet 9 is a search for the true boundary of our solar system. But what happens when we find a mystery that exists beyond our own star? If you were captivated by the hunt for this hidden world, you must learn about it. Oumuamua, the first interstellar object ever detected passing through our solar system. An object so strange some scientists believe it could be an alien probe.